Okay, so welcome to this week's problem set, which will be a continuation of the problem set that we had last week. Yes, so since the sufficiency part of exercise 1 in problem set 2 was very long, we decided to split up this problem set into two exercise sessions. So in this week, we will deal with the necessity part. So we will show that if we have an allocation where, or if we have an allocation which fulfills the condition in proposition 1, then we show that also the conditions in definition 1 are fulfilled. Yeah, so this is the necessity part now. And then we have two additional exercises on public goods. So yeah, let's start. Okay, so as I said before, what we'll do is we will consider an allocation which fulfills the definitions in proposition 1 or the conditions, and then show that also definition 1 is fulfilled. Yeah, so the starting point is following. So assume the following allocation fulfills proposition 1. Or let's state it differently. Let's state it the following way. So assume that this allocation fulfills the conditions in proposition 1. Okay, that's the starting point. What you then can get very easily is that if we take a close look to the two conditions, two different conditions, is that actually condition 1 in definition 1 is basically immediately implied by condition A in proposition 1, and in addition, condition 2 in definition 1 is implied by condition C in proposition 1. Yeah, so those two steps are quite easy, yeah, because those are direct implications. So yeah, let me write this down. So condition 1 in definition 1 is implied by condition A, and condition, I think this was condition 2, if I'm not mistaken. Condition 2 is implied by condition C. Okay, so those two things are quite trivial. The next, like the challenge of this direction is to show that, yeah, also like this allocation which fulfills the conditions in proposition 1 is an allocation where you cannot make anybody else better off without making others worse off. So that's a challenge, even though I must say that it's easier than than the other direction that we had before, that is then the sufficiency part. Okay, so let us assume, so we will do a proof by contradiction. So to show that condition 2 is fulfilled, sorry, it's condition 3. To show that condition 3 is fulfilled, suppose, so we will do a proof by contradiction, suppose there exists some allocation which I will denote by xi tilde and zi tilde. So let's suppose we have an alternative allocation, which makes some individuals better off without making others worse off. So yeah, so this new allocation, so we assumed some like if condition 3 is not fulfilled, yeah, so this is the contradiction part. There exists some allocation, which I denote by xi tilde and zi tilde, such that some individuals are better off and others are not worse off compared to the allocation xie and zie. Okay, so comparing it to xie and zie. Okay, so what is a consequence of some individuals being better off and others without others being worse off compared to the allocation xie and zie? Well, the consequence is that if we sum up the utilities of all individuals under the tilde allocation, the sum must be strictly higher than the sum of utilities under the E allocation. Okay, so consequence a consequence is that the sum of utilities for all individuals under the tilde allocation is strictly larger, than the sum of individuals under the E allocation. Okay, that's a direct consequence. And what we will assume is without this loss of generality, there is no waste. There is no waste in allocation xe tilde zi tilde. Okay, this is without loss of generality because if there would be waste and we would have an allocation which fulfills this inequality here, we could always find another allocation which has no waste and which would then be strictly larger than this allocation here, the tilde allocation. So it wouldn't change anything, but it makes our life a little bit simpler. So what does it mean if there is no waste? Well, it means that the budget constraint in the economy is fulfilled with equality. So this means that the sum of consumption of the private good under the tilde allocation is equal to the sum of endowments in the economy minus, so the endowment doesn't change, that's fixed, right? So it doesn't matter what allocation we consider, endowments are fixed in this economy. So the endowment, the sum of endowments minus the amount of the public good times the production cost of the public good. Okay, and what we also know is that since the XE allocation, so this one here, fulfills the conditions in proposition 3, it means that also in this allocation there is no waste. Okay, so in addition, also no waste in XIE ZIE. I think I flipped it around. Typically I write the numeraire good first. Oh no, I don't. Never mind. So we also do not have waste in this allocation because it fulfills the conditions in proposition 1. So this means, again, the sum of consumption for the private good is equal to the sum of endowments minus the production costs of the public good. Okay, so why is this useful? Well, what we need to do is we need to show that this, so the plan is basically to show that this inequality leads to a contradiction. That's the idea of the proof by contradiction here. So what we need to do is we need to make those two terms in the inequality somehow comparable. And that's what I will be doing now, because if you consider that there is no waste in allocation, you can see that what you will have is that the sum of endowments appears here and it appears here. So it will cancel out from this inequality, and we are left with like a reduced amount of things that we need to care about when wanting to derive a contradiction. So that's the idea. So what will I do now? Well, I will simply substitute. So I will substitute for the sum of zi tilde and the sum of zie with the corresponding expressions here and here. That's what I will be doing now. Okay, so if you plug in, what you have is the following. You will have the sum of endowments minus the production cost of the public good under the tilde allocation plus the sum of the individual utilities for the public good amount under the tilde allocation. So this is then strictly larger than the sum of endowments minus the production cost under the E allocation, production cost of the public good under the allocation, plus the sum of the individual utilities for the public good under the E allocation. Okay, so this is basically what you get when you plug in for the no waste conditions into the original inequality that we had here. Okay, so now as you can see, some stuff cancels out, and if you rearrange this, what you end up with is the following. So this inequality reduces to the sum of individual utilities under the tilde allocation minus the E allocation is strictly larger than C times the amount of the public good under the tilde allocation minus the amount of the public good under the E allocation. Okay, and this is basically what we will use to show that this is a contradiction to so it will lead to a contradiction, so there will be some conflict with the conditions in proposition 1 if we assume that this holds. So we will consider two steps now. The first step is to assume that so we didn't say anything about whether under this tilde allocation there will be more of the public good compared to the E allocation, or whether there will be less of the public good compared to the E allocation. And for the proof to be complete, we need to consider those two cases. Therefore, in the first case, what we will assume, so case 1, is that x tilde is strictly larger than x E. Okay, so that's our assumption that we will make. So the first case that we will have. So since the tilde allocation, since the E allocation fulfills condition B in proposition 1, what we have is that the sum of individual marginal utilities for the public good is equal to C, so the unit costs. So this follows due to condition B in proposition 1. And since this phi function is strictly concave, we have the following. We have that the sum of individual marginal utilities under the tilde allocation is strictly smaller than the sum of individual marginal utilities under the E allocation. So this follows due to strict concavity. Yeah, because XE is larger than X tilde. This follows by strict concavity, and this is equal to C. So we will use this later. What we will do is, so let me enumerate some of the equation, which makes it a little bit simpler to follow my steps. So I will call this condition condition number 1. So this inequality is now condition 1. And please keep in mind, I have a solution manual where the numeration of inequalities or equalities might differ from what I'm showing you here. Yeah, so don't get confused with the numeration of the equalities and lines. So they're not the same compared to the document that I always upload, the sort of solution manual that I always upload in on Moodle. Okay, so this will be here, condition 1. So what we'll do is rearrange 1. And if we do this, so how do I rearrange? I simply divide by X tilde minus XE. Since this is strictly positive, since we consider the case here, it will not change the direction of the inequality. So what we have is that the sum of the following fraction, so phi I X tilde minus phi I X E divided by X tilde minus XE, this is strictly larger than C. Yeah, here I simply rearranged the terms. Now, since X tilde is strictly larger than XE, it follows that there exists some delta, which is strictly larger than 0, such that X tilde is equal to XE plus delta. And if we plug in, so let us call this condition, so this inequality here, inequality 2. So plug in to condition 2. So we plug in for X tilde, this expression here, into condition 2. And what we end up with is the following. So we end up with the sum from I equal to 1 to n of y I xe plus delta minus phi I xe divided by delta is strictly larger than C. And the thing is that due to strict concavity, what we will actually have is that, so wait, let me shrink this here a little bit because I need more space. So, but due to strict concavity, what we actually have is that the sum of phi I xe plus delta minus phi I xe divided by delta. This is smaller than the sum of marginal utilities, so the derivative at xe, and this is equal to c because the xe allocation is fulfilling the conditions in proposition 1. Yeah, so this was our starting point. And now what we have is that, we simultaneously have that this here holds. So this is strictly smaller than c. So the sum here is strictly smaller than c. But at the same time, we have this condition here, which we derived by our assumption that the xe allocation does not fulfill condition C, I think it was. Let me check again, please. Wait a second. Yes, condition 3 in definition 1. Yes, so we basically end up with a contradiction now for this case. Yeah, for the case where x tilde is strictly larger than xe. And so why, I can give a comment on why this actually here holds. So this inequality here. So why does this hold? And I showed this before when we considered the proof in proposition 1. Yeah, so not in proposition 1, in the sufficiency part. Yeah, so this is the same reason. You can simply show that, for each term here in the sum, this term will be strictly smaller than this term due to strict concavity. So I gave you a graph where I showed this, so I draw this, and this applies here as well, and hence leads to the contradiction. Okay, so this was case 1, and now we will consider the other case. So we will consider the case where we will produce less of the public good under the tilde allocation. Now we consider xe. So this is condition 2. So x tilde is now strictly smaller than xe. Now, condition 1, so not condition 1, sorry, equation 1 becomes, because now we're dividing by something negative, it becomes the sum of phi I xe minus phi I x tilde divided by xe minus x tilde being strictly smaller than c. Okay, and now since x tilde is strictly smaller than xe, we have that c equal to the sum of marginal utilities at xe is strictly smaller than the sum of marginal utilities at the x tilde allocation. Okay, so this is the implication of producing less of the public good in the tilde allocation because xe is fulfilling the conditions of proposition 1. Okay, and now since as well, so this is another implication, since x tilde is smaller than xe, we also have that x tilde must therefore be equal to xe minus delta for some delta, let me be precise here, for some delta which is strictly larger than 0. Okay, so now we have the other case, x tilde is smaller than xe, therefore some delta must exist, some amount of the public, so some number must exist such that if we take away some amount from xe, we end up with the amount of the public good in the tilde allocation. So now what we have, so let me call this condition here condition number or equation or inequality number 3. Therefore, 3 becomes the following. If we substitute for this expression here into 3, we end up with the sum of phi I xe minus phi I xe minus delta divided by delta being strictly smaller than c. Okay, so this is what we end up with. But now, again, we have a contradiction because the following, due to strict concavity of phi, what we have is that actually the sum of phi I xe minus phi I xe minus delta divided by delta. So this is actually strictly strictly larger than the sum of marginal utilities at xe, which is then equal to c. And therefore, we have a contradiction because here we showed that due to strict concavity, this here must be strictly larger than c. But if we assume that the E allocation is not fulfilling condition 3 in definition 1, what we end up with is this condition here. And this is a contradiction because it cannot be larger. So the left-hand side here, so this here is equal to the left-hand side here. And it cannot be strictly smaller than C and strictly larger than C at the same time. Therefore, contradiction. We have a contradiction for both situations, whether xe is strictly larger than x tilde or whether x tilde is strictly larger than xe. Therefore, so as a consequence, this x tilde or so as a consequence of what I showed you now, this x tilde allocation zi tilde, which makes some individuals better off while making nobody worse off does not exist. Or let me be more precise, worse off compared to xie, zie, so the allocation which fulfills the conditions in proposition 1, does not exist. Yeah, because we assumed that it exists, and with its existence we have a condition which must be fulfilled, and we showed that this condition leads to a contradiction to the initial assumption that we had in that this this E allocation fulfills the conditions in proposition 1. Yes, so we end up with a contradiction.